Okay, thank you, Debbie, for introducing the study. These are my disclosures. What I would like to do, I would like to take you through the technologies that we specifically set up for this unique study. And I would also like to present you first data because I think it gives you some flavor of the type of data which you might get out of that study. So clearly our major question is, how does the immune system decide whether or not to develop inhibitors? And you all know if a patient with severe hemophilia A is treated with factor VIII, he can either develop inhibitors or he stays free of inhibitors. And really we have almost no understanding what's going on in the immune system in this range here when inhibitors are being developed or when the immune system is turned down, is tolerized, and patients are fairly stable without inhibitors. Now, as you can all imagine, it's very difficult to do immune biomarker monitoring in infants. We are talking about small babies. You cannot really apply the standard technologies that are used in other diseases where you deal with adults. And therefore, we developed special setups that can be applied and can be done with small sample volumes. So the first thing is we do a very comprehensive analysis of anti-factor VIII antibodies. Of course, we do the standards. We look for neutralizing activity, factor VIII inhibitors. But then we also do a very extensive characterization of factor VIII specific antibodies, including isotypes and Ig subclass profiles. And what we also do, because we think this is very essential if you want to understand evolving immune responses, is that we set up a technology that enables us to assess apparent affinities of antibodies differentiated for isotypes and subclasses, and we do this by competitive ELISA technology. What we also do, we look for signatures of factor VIII-specific transcriptome patterns in PBMCs, and for this purpose, PBMCs are re-stimulated with factor VIII in vitro. We do epigenetic analysis of methylation patterns at specific marker loci of different immune cell populations to get some idea about the immune status. And here, these are the assays that we have started with, like T cells, Treg, Th70, and K cells. Now, another set of these assays is available, and we are just discussing to include them because we have some material left. And finally, we also would like to use this precious material to do whole transcriptome studies in whole blood to monitor longitudinal changes in pattern of mRNA expression profiles. This is an overview of the first patients who completed our exhibit HIP study. As you can see, we have all the different flavors that you can expect. We have patients who are very stable, who don't develop any antibodies at all. We have 3 patients who developed inhibitors at exposure day 6, 10, and 20. And we have patients with very persistent low affinity non-neutralizing antibodies that do not develop into factor VIII inhibitors. And I would like to show you, as an example, the kinetic of antibodies of these 3 patients. One is a patient that stays stable without any detectable antibody. One is a patient that developed factor VIII inhibitors at exposure day 20, and one is a patient that developed non-neutralizing IgG1. This is the patient that never developed any antibodies, and you can see whatever we looked at, and we really looked at the whole repertoire, we could never find any antibody that was detectable in the assays we used. This is a patient that developed an IgG1 antibody that stayed persistent during the whole study period. We looked into the affinity of this antibody, and it is a low affinity antibody that resembles the type of autoantibodies most of us have, or all of us have, but we don't really understand yet what the biological significance of these antibodies are. They are low titer but can be detectable. They are not pathologic, and what is important, they are low affinity. And then we have this patient where you see a typical development of factor VIII inhibitors, and what is now possible with this study is that we get some idea about what happens before the inhibitor is detectable for the first time. So you can see this patient stayed without inhibitors, and then at exposure D20 we could detect the inhibitor for the first time. And if you look at the other antibodies, then you realize that prior to the first detection of the inhibitor, there were IgG1 antibodies that were also already detectable. And what you can see here, and this is very much in agreement with how we understand the modulation of antibody responses, we know that IgG4 antibodies can be found in almost all patients with established factor VIII inhibitors, and they reflect a fairly matured immune response. But if you now look at the early kinetic of development, then it becomes more and more clear that IgG4 is important, but it's not the first antibody that is detectable. And if you look at the affinity of these antibodies, and here you can see the apparent affinity of these antibodies, you can see here is IgG1, IgG3, and IgG4. Initially, this patient had low to moderate affinity antibodies of the IgG1 subclass. They stayed for a certain while, but then starting at exposure D6, we could already detect a high affinity antibody, even though this patient was still inhibitor-free. And you can see that this clone stays over time, doesn't really change in affinity. The only additional findings that come later on are high affinity IgG3 and high affinity IgG4 antibodies. So it's pretty clear that these high affinity IgG1 antibodies could be detected prior to the first clinical doses of the inhibitor. Now, the next set of assays I would like to present to you are epigenetic analysis of certain immune cells. As you can see, they can be detected using very small amounts of whole blood. You can freeze the whole blood, so it's a very, very easy setup to monitor changes in immune cells and circulating immune cells. These are not factor VIII specific immune cells, but they are total immune cells that you can pick up in peripheral blood, and they might give you some idea about immune status of the patient. It might give you some idea when that patient's immune system responded to some perhaps external stimulus. And here, in these first patients, we applied an epigenetic CD3 assay for 3D3 total T cells, an epigenetic FOXP3 assay to assess numbers of regulatory T cells, an epigenetic IL-17A assay to assess Th7 pro-inflammatory T cells, and also an epigenetic granulocyte assay to assess natural killer cells. For these types of assays, we worked with a company called Epiontis in Berlin, that is specialized for setting up these specific epigenetic assays. And in order to somehow validate these assays, we could not use samples, blood from healthy infants because it's not possible to access them, but we used healthy adults. And here you can see the type of ranges you get when we analyzed 20 healthy adults. And the interesting aspect is here that you get some idea where the normal ranges are in the healthy adult population at all, but you can also get some information how the immune system in general looks like in these infants in comparison to adults, because there are hardly any data available that would tell us what cells can be found in the circulation of these patients, of these youngsters. And this just shows you the first two cases, and I will show you the rest afterwards. It illustrates you, this is the kinetic of FOXP3 CD4 T cells in peripheral blood, and it tells you quite easily that the levels of FOXP3 regulatory T cells that you find in these babies are already fairly comparable to adults. So babies have already fairly normal levels of regulatory T cells, what might tell us that it is easy to induce tolerance. It looks very different for Th17 cells. As you can see, you hardly find any Th17 cells in the circulation of these babies. Th17 cells are known to be pro-inflammatory. They are involved in inflammations, in the induction of autoimmune diseases, and based on these data, it is likely that they're built up over life, during infections, during diseases. These are the values that we get for NK cells. You can see that we can detect NK cells, although they seem to be a little lower than you would find in adults. And just to give you a flavor and an overview about the data that we found, here you can see 8 patients where we measured the FOXP3 regulatory T cells in the circulation over the first 50 exposure days. You can see that they are all somehow in the range of what you find in adults. They are fairly stable over time. You see differences, but they are all within the ranges of healthy adults. What you can also see, there are some patients that show fluctuations in the levels. There are other patients that are fairly stable. Now we included here 2 inhibitor patients. These are the patients, the 2 patients that developed inhibitors at exposure day 6 and exposure day 20. And you cannot immediately see any differences of these patients, although we have to wait for the end of the study. Here, as I said, very different, the picture of pro-inflammatory Th17 cells in the circulation. You see that they are very low compared to the ranges of adults. But what you can see is that there are patients who have persistently low levels of Th17 cells, and there are other patients where you have some fluctuation. It goes a little bit up and down, like this patient, maybe also this patient. And if you look now at the 2 inhibitor patients, then you can see that maybe these are a little different from, for instance, these 2 patients. But this is just early impressions. It's far too early to speculate, and we have to wait for the final results. What is quite interesting is the level of circulating NK cells. Here you can see that you have patients like this one where you have an up and down, where you really have high fluctuation, which might indicate that this particular patient had to deal a lot with external events like virus infections, maybe also vaccinations. This is something we still have to do at the end of the study, that we go back and see if there's anything known that happened around this time. But this patient here is very, very, very interesting. Then you have patients who have a little bit of variation at low levels. You have patients that are very persistently low, and you have patients that show moderate variability. Again, the 2 inhibitor patients, and this is quite interesting, that this patient that shows the highest variability in NK cells is also a patient that developed factor VIII inhibitors at day 20. As I said, this is just the very first data, and I wouldn't really draw any conclusion. I would just like to illustrate the type of data that we can collect these days. This is an interesting case here. This patient had fairly consistent levels of NK cells, but at one exposure day, we found a pretty high increase, a peak. Interestingly enough, this patient had one peak, a temporary IgG1 antibody that was of high affinity that could only be found on this particular exposure day. The inhibitor was negative in the central lab, but was slightly above background in the local lab, so it would clearly be defined as inhibitor negative. But it might indicate that there was something going on in his immune system around this time, and we have to go back to clinical data to see if this patient had an infection around this time. This is what I can show you today, the transcriptomic analysis and maybe also a metabolomic analysis we will do at the end of the study, because we think that it is worth waiting until the end of the study. Technology is developing very rapidly at the moment, and we would like to make sure that we have the most state-of-the-art technology for metabolomic analysis and deep sequencing for the transcriptome analysis. I would like to summarize that modern technology for antibody analysis and immune cell analysis facilitates longitudinal studies in hemophilia infants. I hope I have convinced you that the sole assessment of factor VIII inhibitors does not uncover the complexity of antibody responses against factor VIII. We believe that additional analysis, such as isotype and Ig subclass analysis, as well as affinity assessment, will provide more comprehensive data sets. The first results that coming out of the HIP study highlight that factor VIII inhibitor development is associated with the development of high-affinity antibodies, as we had previously proposed. There are persistent non-neutralizing antibodies of low affinity, and we also find them in adult hemophilia patients who never had factor VIII inhibitors. So this is certainly a species of antibodies where it would be interesting to understand the biological significance. There is some hypothesis that low affinity, low titer autoantibodies that we all carry to some extent might be important for the maintenance of immune hemostasis. But this is a theory, this is out there in the literature, and I think there are not enough data to really understand the impact of these low affinity non-neutralizing antibodies. And I've presented to you first data of epigenetic analysis of methylation patterns of validated gene loci in peripheral immune cells, and we started with regulatory T cells, Th7 cells, and NK cells. And the data reveal a unique pattern for infants when compared to those of adults. So I think it's interesting, not just for the hemophilia community, but I think it's interesting in general to understand how the different immune cells that we find in the peripheral blood of adults is evolving in these babies. And with this, I would like to acknowledge all the many people who have contributed to the study. Debbie has already highlighted the great efforts and energy of the investigators that participated in the study. I would certainly also like to thank the patients and the parents in particular who took the step and agreed to include their babies in the study. Of course, the study couldn't be without Debbie and with Debbie Brown, who is the principal investigator in the US, and with Elena Sant'Agostina, who is the principal investigator in Europe. But it's very important is that we did a center qualification to make sure that the quality of the data that come out of the study meet our expectations. And here I would like to thank Elisabeth Donacci from the University of Texas and Christoph Hofbauer and Birgit Reipert from my team who did the center qualification analysis. And I wouldn't want to end without acknowledging from Ro, who is the study coordinator. And with, I thank you for your attention.